Hi all, good morning to everyone. In the last session we have seen the fundamentals in algorithms. We have defined the term algorithm and we have seen the criteria of an algorithm and the ways of representing an algorithm. So clearly we have seen that algorithm is an unambiguous procedure which consists of a finite set of steps that takes the finite amount of storage and finite amount of time to complete the execution. Can anyone recall the different criteria of an algorithm? What are the criteria of an algorithm? Anyone? Vaishnavi,
Sir,
what are the criteria of an algorithm?
input, output, finiteness, definiteness, effectiveness.
Yeah, input, output, finiteness, definiteness, and effectiveness. Very good. We have seen, right, the stepwise procedure to solve the problem. That is an algorithm. We have defined the algorithm in terms of steps. For example, step 1 start, step 2 input the variables, step 3, 4, etc. processing, step n stop, step n plus 1 n. So the way in which we are writing the algorithm is important. We need to define the finite number of steps in terms of well-defined instructions. Each step must consist of well-defined instructions. Step 1, step 2, step 3, etc. Step n, step n plus 1. For example, start. Here we have end. N. We have explored some examples, right, how to write an algorithm for the given problem. Hope all of you have gone through this. If you have any queries, right, first we can ask. Have any doubts in the last session?
No, sir.
Okay, good. In this session, we focus on the ways of representing the term algorithm. The term algorithm can be represented as a pseudocode. Pseudocode. Pseudo means false, right? It doesn't mean right false code. Instead, we need to write the normal English-like statements. English-like statements to solve the problem. That means whatever we are going to state in the steps can be defined right like a procedure or some statements 1, 2, 3, 4, 5, 6, etc. We need not number it, but we can provide the procedure right how to solve it in terms of normal English like statements. So this is one way to represent the algorithm. The second way to represent an algorithm is a flow chart. Flow chart, this is the diagrammatic representation to represent or to specify the term algorithm. So algorithm is represented either using a pseudocode or using a flowchart. This is a diagrammatic representation. With respect to the diagram representation, we can have several symbols in it so that the procedure, whatever we are going to write in the English-like statements are going to be drawn as the diagrammatic representation. So flowchart, which shows the flow of processing. However, input is given as the beginning to the algorithm, how the algorithm is producing the equivalent output. This is drawn, right, using a diagrammatic representation called a flowchart. So in this example, we are going to see, right, some problems, how to solve those problems using pseudocode, flowchart, and algorithm, and giving the trace for the given problem. First, to write the pseudocode normal English-like statements, we need to write the procedure as it is, similar to the stepwise procedure for solving the problem as in the algorithm. Second, the flowchart is concerned. There are certain symbols to be used. Symbols required to construct a flowchart. First one, this is the oval symbol. This is used to represent beginning as well as end of the flowchart, start as well as end. Then this one, parallelogram, is used to define the input and output operations. Input output operations are defined using this symbol. Then normal rectangle, this is used to represent the computation or computational statements. Then this one, checkbox, the decision box, diamond symbol, right? This is used to check the conditions. Checking the condition if it results in true or false. Ultimately, right, we need to represent the true flow, right, as well as false flow. Then this is the continuation mark, continuation symbol. In case the flowchart is not fit in one page, finally we need to put an arrow mark like this. This is arrow mark that is used to indicate the flow of direction. Finally, the flow of direction should reach this symbol. Inside this, we can represent some letters A, B, C, D. Then in the next page, we can start with the same symbol, right? Small circle and letter. Then put the flow of direction. We can continue. In some cases, if you want to store the output, the hybrid symbol is introduced. This is the hybrid symbol. Oval as well as this checkbox. This is used to store the output in terms of variables. These are the symbols used in the flowchart. For example, see one example here. The problem is find the given integer is odd or even. This is the problem. Let us represent that using pseudocode. in pseudocode, assuming that the integer is n. So check if n is divisible by 2. What we can write in pseudocode, normal English-like statements we can write. For example, I am writing check the given integer n is divisible by 2. If n is divisible by 2, that means if 2 is the divisor or factor of n. If n is divisible by 2, then we can say that n is even number. If n is not divisible by 2, or otherwise, if n is not divisible by 2, then n is odd number. So whatever is a given problem, we need to write the normal procedure in terms of English-like statements. For example, statement 1, this is statement 2, this is statement 3. This constitutes the initial process to the program development called, right, the pseudocode, or this forms the basis of the flowchart development or algorithmic development. In this case, how do we write the algorithm? Step 1, start. Step 2, input the variable n. Step 3, if n mod 2 is 0, then n is even, and print the result and print it. Step 4, if n mod 2 is not 0, then n is add and print the result. Step 5, we can terminate the process, stop. Step 6, we need to end the algorithm, right, end at the final step. This can be drawn as a flow chart, right? The simplest way we can write here, for example, start. This will be returning the oval symbol. Then we need to write getting the input value. For example, input an integer n. This will be drawn in the parallelogram. Start input n. We need to read the value of variable n. Then we need to check if n is actually divisible by 2. So apply the modulus operator. In the last class we have explored the purpose of modulus operator. Then check if n mod 2 is equal to 0. So I write in terms of the conditional flow. if n mod 2 is equal to 0. If n mod 2 is equal to 0, in the true block, that means if this is S, here what we have to do, we need to print n is even. So I write here S, print n is even. So input output can be represented using this parallelogram, or if you want to store the result, right, you can use this hybrid symbol. So here, right, for example, we represent using the say parallelogram. We are printing print n is even. This is the case when n mod 2 is equal to 0. Else, for example, here I write the condition no. If the condition is false, here we write print n is add. Put it in the parallelogram. Then finally we need to terminate the process, right, by writing the stop. So here I write stop symbol. Write it in the oval shape. Join the flow direction from here. After printing either n is even or add, control is transferred to print the results. Or sorry, after printing this, right, we need to terminate the process. So to terminate the process, here, right, we have merged print n is even, the next step is stop. Print n is add, the next step is stop. So this is the flow diagram or flow chart to check if the given integer n is odd or even. Suppose if we input n is equal to 5, here n is equal to 5. As a flow diagram, we need to execute the steps. Start, input n is equal to 5, checking if n mod 2 is equal to 0. Here if you want, we can put a question mark. That is a clear indication to check if this is a condition. N mod 2, 5 mod 2 is not equal to 0. 5 mod 2, this is equal to 1, right? Then you can put right double equal or single equal, right? No problem. In programming for the conditional test, we need to use double equal. So if 5 mod 2 is equal to 1, right? This is not equal to 0, not equal to 0. So condition is tested, and in the false part, right, we need to print the message n is add. So n is equal to 5. This is odd number. Suppose n is equal to 20, 20 mod 2 is equal to 0. In this case, 20 mod 2 is equal to 0. Condition is yes. You need to print the message n is even, and you need to terminate the process. Stop. So this is a way, right, to solve the problem, right, at the beginning, right. So try to write the normal English-like statements. Then you can write algorithm, or even you can construct a flow chart, right. The second one, right, try to construct a flow chart. You can write the algorithm. Then the third step, right, you can write the algorithm in terms of procedure, step 1, step 2, step 3, etc. till reaching the steps stop and end. See the next example. This is the first one. Checking if the given integer is odd or even. Let us solve other problem. Second one, find the minimum of numbers So to find the minimum of three numbers, we start with the pseudocode. In the pseudocode, we are assuming that the three numbers are, for example, A, B, C are the three numbers. In the pseudocode, we need to write the normal English-like statements. After reading the numbers, for example, if you want, you can write read or input. Read or input B numbers. Compare first with second and third. Compare the first with second and third to check if first is, here the problem is minimum. Okay, first is minimum. So if we compare A is less than B and A is less than C, ultimately A is the minimum among three numbers A, B, C. So this process is over when A is compared with the remaining numbers B and C. A will be the minimum. When A less than B and A less than C, condition is true. If not, we need to compare second and third. Compare B, second and third to find the minimum. Then we can print the results. Print the result. So normal English-like statements are introduced here. We have stated the operations, for example, try to read or input three numbers. Compare the first number with second and third number to check if the first number is minimum, because the problem is we need to find the minimum of A, B, C. So given three numbers A, B, C, the problem is minimum of A, comma B, comma C. This is equal to question mark. That we need to solve. So once the first number is compared to the second and third and concluding if first number is minimum, right, no problem, that can be printed in the next step. If not, when A is compared with B and A is compared with C, then ultimately to check if B is minimum or C is minimum, it is enough to compare the second and the third numbers to determine the corresponding minimum. Finally, we need to print the result. This is the normal pseudocode. Normal English-like statements are written to solve the problem. Once the pseudocode is over, you can go for writing the algorithm or you can construct the flow chart, right? So whichever is right easier to use. But pseudocode writing, this is not necessary, right? You can write the algorithm and a flow chart, that is necessary. For example, here we do like to construct a flow chart. Step first, we need to start. This will be returning the oval symbol. Then what we have to do, we need to get three numbers. We read, right? Try to read three numbers, A, B, C. Here I write input A, B, C. Input is written in the parallelogram symbol. Flow, right? Start. Flow is written. Input A, B, C. Then checking if A is, that is first is greater than second, and first is less than second, and first is less than third. So here I try to write check like this. A is less than B, and A is less than C. So this will be drawn in the checkbox like this. I put a question mark here. A is less than B, and A is less than C. In case the condition is true, then what is the meaning? Here we can write A is
Sir,
minimum. Since A, yes,
sir, can you also use else,
Yes.
elif method?
what on?
Elif method, sir.
Tell me.
Else if.
What one? Else if, right? That is also possible. You can first check if A is less than B, then further check, right? If the condition is true, then check if A is less than C. Or you can combine the two conditions here. If A is less than B and A is less than C. So I am constructing the flowchart first to check the combined condition. A is less than B and A is less than C. If it's so, then here I can print R. As we discussed earlier, this is the combined symbol. I can store minimum is equal to A. That means the variable A is stored into another variable minimum. When A less than B and A less than C, this is true. Yes. If not, no. So when the condition fails, either A less than B fails or A less than C fails. Ultimately, A is not a minimum 1. That stage, there is a possibility to check B and C to conclude the minimum. So when this is happening, no, further we need to check if B is less than C. Checking if B less than C in the checkbox. If B less than C, in case if this is true,
Excuse me, sir.
yes, yes,
Sir, sorry to tell this, but sometimes your handwriting is not that legible, sir.
1 minute, tell me.
Sir, some places the
Yeah.
handwriting is not that legible, sir.
Okay, I
Not
try to
complaining,
write,
sir.
right?
Just telling, sir.
Okay, I try to write clearly, right? Because this is the online session, right? It seems when I am writing, it seems the characters are going to be displayed, right? Little bit late. That's what we have that effect. But later, right, you can go through the shared material, right? So that you will see the clear effect, right, in the handwriting. So here if B less than C, if this is true, then what is the meaning here? minimum, this is equal to B. Yes, if B less than C is true, then minimum is B. In case if the condition is false, no, then here we can write, what we have to write? We need to write minimum is equal to C. For example, here I write minimum is equal to C. So when A is minimum, the conditions A less than B and A less than C are tested. Accordingly, we have assigned the variable A to minimum. Else when B less than C is true, we have assigned the variable
Sir, I have
B
a
to the
doubt, sir.
minimum. And yes,
Sir, in the right hand side
Tell
of the
me.
if statement, B is lesser than C and B is lesser than A should also come, right?
where here second checkbox.
Yes, sir.
Are you mentioning in the second checkbox? Not necessary, because here comparing three quantities A, B, C. Initially checking if A is less than B and A is less than C. If any one condition fails, ultimately A is not a minimum quantity. So it is enough to compare B and C further. That's what here when the condition fails, compare B and C alone. If B is less than C, can conclude minimum is B, right? Then if the condition fails, we can conclude minimum is equal to C. Clear?
Okay.
Clear or not? Then finally what we have to do, because of the space I am writing here, print minimum input output. So here I use the parallelogram, then join here, this one should be joined with minimum is equal to P, then here also actually, right, we need to combine these three into a single flow here, print minimum. Then we need to stop the execution, start, finally use stop. This is the flow diagram or flow chart figure. Flow chart to find minimum of three numbers. Minimum of three numbers. Understand or not? We have obtained three input numbers A, B, C, compared first with the second and third to check if first is minimum. Then we have compared second and third to find out either second or third is the minimum. Finally, we have printed the quantity minimum. Then we stop the flow of execution. Pseudocode is over. Second, the flowchart is over. What is the next step? We need to write the algorithm. So here I am writing the algorithm. Please take it. Algorithm, step 1, start. Step 2, what is step 2? We need to input three numbers. Step 1, start. Step 2, input three numbers. in the variables A, B and C. Then step 3, in step 3 we need to compare first to the second and the third. So how do we write the step in terms of if conditional statement? If A is less than B and A is less than C, if this condition is true, then we assign A to the variable minimum. Minimum is equal to A. Step 4, here the condition is false, right? So we can write the else statement starting from here. Else, if the condition fails, further we can check B and C. Else if B is less than C, then minimum is equal to B. Minimum is equal to B. Else we can also write in the same step, or we can move it to the next step, right? Else, what is the minimum?
C.
Minimum is equal to C. Step 5, we need to print the minimum. Check if the handwriting is okay now. Step 6, we need to stop the procedure. Step 7, we can end the process, terminate the process. End. So the pseudocode, this is converted into the diagrammatic representation. Then the diagrammatic representation, this is converted into the equivalent algorithmic representation. The next step is we need to check if the algorithm is producing the correct result for all possible inputs. For example, here we do like to do the trace